Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to EV Components Review. We are looking at the power stage for a Talaria controller. Or, I'm sorry, we're looking at the logic board for a Talaria controller. And this is the CPU, and that is a Nuvoton NM1520. This is a 50 megahertz CPU. It's not particularly fast, so there's a pretty good chance that this chip does not have the capability of handling field-oriented control. It's probably just doing, standard sinusoidal stuff. And that was my opinion just looking at it from physical size previously, that this was probably just sinusoidal. And, based on the specs from the datasheet for it, I would say that's probably still very much the case. It does have some interesting functionality. Like it's got CAN bus functionality and UART and different things like that, so it can communicate with outside stuff pretty well. But yeah, it's probably not powerful enough to do field-oriented control. And if I'm wrong about that, well, feel free to correct me down in the comments below. I don't mind being wrong at all. Yeah, in fact, when people do that, then we all grow and we all learn. So right here, this part, that is a 7805, and if I tilt it, there we go, you can see the part number, 7805 on there. And that is a 5-volt linear regulator. And over here, in that little chip right there, which says ED492 on it, 493, I couldn't find this part. I looked and looked and looked for it, and I was not able to find that thing. But, it's obvious. You have an inductor right here and a couple capacitors and a couple diodes and things. This is a buck DC to DC converter, so that's definitely a buck controller right there. It doesn't do anything else, most likely. Anyway, I was not able to find that part, so after a while I finally gave up and said, well, never mind, we'll just move on. You can see a couple parts right here, and I saw another one here just a second ago. Yeah, there we go. The potting is really, really hard. So, you can see it all crusted in amongst the legs of things. This is really hard stuff. I mean, I'm picking at it with my spooger, and it doesn't even go anywhere. This stuff is like a rock. Yeah, so it's in amongst everything, and it pulled up a bunch of components. Depotting this thing was a bit of a chore, to say the least. It took a lot of effort, a lot of heat, a lot of reheating. Because, I had to keep the whole board hot enough that it wouldn't melt any of the solder, but it would at least soften the potting. And then it'd only have a couple minutes while the potting was still hot enough to be able to peel up bits of it. And then I would stick the whole thing in my toaster oven and heat it up again, and then pull it out after a few minutes when it was hot again, depot some more of it, and yeah, it took a good little while to depot this stupid thing. Right here, you have a gate driver, and that is specifically, hold on a second, got to find the part again. There it is. So that's an international rectifier, IR2101. They're good up to about 600 volts. So, it's going to definitely exceed anything that this controller might possibly do. They are also rated for 100 milliamps. So they're not a very powerful gate driver, but these MOSFETs right here are supplementing its output power. So, this gate driver is basically turning these MOSFETs gates on and off for high side and low side MOSFETs. And like this MOSFET, or this gate driver right here, it's got MOSFETs here and here. Whoops, let me shift that down a little bit. There you go. Yeah, you've got the same thing again. So you've got a couple of MOSFETs right here and two more right there. And they're supplementing gate drive from these gate driver chips to be able to beef that up some. And that's because the MOSFETs that are on the power stage need a bit more current than a lot of other MOSFETs do. Anyway, yeah, that's kind of what their job is. All right. Yeah, it's kind of interesting. You've got an LED on this board that you can't see when the thing is all potted. So why the hell do you do that? I don't know. But then again, EBMX, they do the same thing. There's probably 6 or 7 LEDs on their logic board, and it gets all potted as well, right? So, yeah, you don't get to see those LEDs, but I do have a picture of them all lit up. So it seems kind of strange that they're there, but they are there. All right, so this chip right here, this 3-peak TP2264, that is an op-amp package. So basically, a couple little amplifier chips inside there, 4 of them to be specific. There's a 2261 and a 2262, and those have 1 op-amp or 2 op-amp, and the 2264, which is what this is, has got 4 of them in it. And it's basically taking little signals and making them into big signals. What exactly that might be, I don't know. My guess is maybe, because here's a current sensor right here, is maybe these signals coming off these things are kind of weak, and you need to amplify them some. I'm just guessing because I don't know. But at least I can tell you what the chip is. Anyway, yeah, right here you can see one of the 3 phase current sensors, and you can see these little protrusions out here in the corners. So you'll see these in a minute on the bottom, but there is a stud, a little metal stud that goes in each one of those things, and then this whole entire ring is then soldered down to the board via those studs. So it doesn't go anywhere. It's not like the Suron, which I will show you after a while, that these can be moved. They couldn't be moved because those ones are just glued down. These ones, nope, they're soldered in place. And then right about here, there is a linear hull inside there. So all this shiny stuff on here and all inside the center of it, that's all potting. And in fact, like there, you can see those ridges in there. Yeah, that's the potting. Yeah, this stuff was a pain in the ass to get out, to say the least. Yeah, and as a result, I pulled up parts and things, on the board in a lot of places. Yeah, right there, there's a diode that's missing. Yeah, a lot of parts just simply would not come loose and came up with the potting, and there wasn't anything I could do about it. So as far as like repairability, this is kind of the nature of hard potting. It's a bear. It's not going to make repair easy. Here is your 3rd phase driving circuitry, and again you've got another one of those same 2102 chips, or 2101s rather, and then you've got a couple MOSFETs here and a couple here, and that's supplementing gate drive. Yeah, you can see there's a capacitor pulled up. Here's 2 more pulled up. Yeah, there was a diode there. Yeah, this was suboptimal, to say the least. I can't say I'm overly fond of hard potting. Soft potting is much more easy to work with. Yeah, there's the connector for going down to the power stage. Here is obviously your I/O connector, and there's these small diodes here. This is for protection. So it's going to let signals go out of here, like say for halls or something else. I don't know exactly what, but the diode junction is a one-way street, so it allows current to flow one way but not the other. Yeah, and I don't know what a T4 diode is specifically. That's just something, maybe just a little silicone diode or something. I don't know. Anyway, yeah, diodes allow current flow in one direction only. All right. So there is a crystal right here. So this is basically a clock chip. It's a piezo crystal inside there. It vibrates at a rather specific frequency for something. Being that it comes over to this little 8-pin chip here, that is very likely to be what it's for. This chip suffered damage. Anyway, this part right here that's right underneath my spooger stick, that's the actual top of the chip. And this part over here all got pulled up. So yeah, I don't know what that part is. It's a thingy. I don't know what it's for, don't know what it does, but yeah, it's kind of not there anymore. This little chip right here, so let me look at that one again. Don't remember what that part number is off the top of my head. That's right, that was the one I couldn't read. Yep. Yeah, it's partly gone. Oh wait, nope, that's... Yeah. So you can see that chip down there. So that's another 3-peak chip. And that's a dual op amp. I did find that one. So I'm wrong on that part. Yeah, there it is. So that one is called a TP10. And it is a 10 megahertz dual op amp package. I'm not sure what an RRIO op amp is. Yeah, it's again taking some small signal and making it bigger. And then right next to it, this is a capacitor, but yeah, there's that TP10 chip. All right. So right here, you've got a 122M3, and that guy, I have that one looked up too. There it is. So that is by a company called 2Pi, and actually you can see the pi symbol right there on the thing. Yeah, that chip is a dual channel digital isolator. So inside this thing, and let me flip it this way, kind of get it on a little bit better. All right, so yeah, you can see it goes over to this chip, whatever that was. But yeah, these two legs right here, they are the input side, and these two legs here, I think I'm saying that right. Nope, I've got that backwards. Those are the input side, and those are the output side. So this chip inside here, it's got a capacitive isolation inside it, if I remember right. And so these two legs right here, so they're like data out from this chip over here, which I'll talk about in a minute. And they charge that capacitor up, and then this side reads that capacitance and then sends it on to whatever that was. Anyway, yeah, so this is basically just a isolation component because this right here is actually a CAN bus chip. And so this is a protection device to protect this controller against external things going badly wrong. You know, it's very much like those isolated DC to DC regulators or the capacitively isolated gate drivers that were like, say, on the Tronic 750 controller. This is doing very much a lot of the same things, but it's doing it specifically for CAN bus. So one of those two wires is transmit and the other one is receive from CAN bus, most likely. Yeah, that's exactly what it is. So one of them is out and the other one is in. So yeah, we could say this one is going, like, say, from this direction to this direction, and this one is going from this direction to this direction, or the other way around. But yeah, that's just a little isolation chip. And then this right here, this MCP 2515, that guy is made by Microchips, and you can see the Microchips logo on it. And yeah, like I said, an MCP 2515, and they call it a standalone CAN controller with SPI interface. So it's got the CAN transceivers in it. It's the full CAN controller, so it does, you know, digital ones and zeros and turns it into CAN bus protocols. Yeah, that's all done inside here, and that's all done at a very specific frequency. And right there. So and then of course it's got its own clock chip. Yeah, you can see potting stuck to the top of the thing. Now the potting did not come up particularly well. All right, last thing I want to show before I flip this thing over is you can see, like, right here, and there's another one over here, yeah, right there, and you can see it's labeled ground, and over there's another one, so yeah, ground 4, and then like up there, you can see that one says VBus 1, and there's another one, VBus, whatever that is, 4, and here's another one over here, VBus 3, yeah, no VBus 2, that's kind of weird, right? 1, 4, and 3 in different order, but anyway, yeah, so you can see all of this copper up here. Oh, come on, camera, focus. Focus, not on that, on this stuff. But yeah, all that's battery plus in there, and all of this right here is all battery minus. All right, let's flip this thing over. There we go. Yeah, and then again, right here you can see the other side of that battery plus, and it's all across the back side of here, all the way across over to here. So anyway, some of the current path for the power stage is right here on both sides of the board, and the same thing for the battery minus, which is significantly larger. You know, it's got a lot more trace on the top and the bottom than the battery plus does. Yeah, you can see all the little vias in here, and there's one of those through holes. Whereas battery plus, you know, it's got vias through here, and then it has them at the capacitor legs, and that's pretty much it. So battery plus is not reinforced anywhere near as much as battery minus is, which seems kind of odd. But yeah, that's how it's done. All right, so right here, you can see this, this, and this. Those three solder positions, those are the three legs that secure this shunt current sensor from the other side. You can definitely see all those ridges right here from where the potting goes in. And those 3 solder pads, those are from the linear Hall, which is basically a magnetic sensor. And yeah, then they send one of those 3 legs, probably goes through the center of the board over to some other place to get cleaned up, optimized, or whatever. Right here and right there, that's the bottom side of those connectors, which you saw next to the MOSFET drivers. And that's where the pin headers come up into the logic board from the power stage to get control signals down to the MOSFETs and temperatures and whatever else might happen. Yeah, and over here, there's your other one. Right there is the underside of the logic connector. You'll notice all of this pad right here, and it goes all the way over here to there. This is battery minus, and like I showed this on the EBMX controller, the X9000, that there was a big piece of copper across the bottom of the board. Well, that's exactly what this is doing. And if you'll notice right above it, this right here is also battery minus, but it's not connected to all this stuff. And that's because this makes for, kind of a sort of isolated ground plane to protect all the small electronics from noise from the power stage. So anyway, yeah, this runs all the way across the bottom of there, and the only place it connects to anything on bat minus is at that one spot. So yeah, it's basically acting as an RF shield. Alright, so that's pretty much everything on the logic board that I really want to show you. The next video is going to be the power stage. I guess there's one last thing there, so that's the programming port for this thing, so whatever plugs in there. But yeah, I think that's pretty much everything I want to show you on this board. Reasonably well designed with some stuff. I never like seeing power stage reinforcing being done on the underside of the logic board. This is meh. It's not very good. You really should do that all on the power stage and not have anything up here needed for anything other than like ripple filtering and for powering what little bit of current you need up on the logic board, and that's about it. So yeah, it's an okay design. It could be better. Yeah, it definitely could be better. Anyway, yep, I think that's probably everything I want to talk about with the logic board, and my next video will be the power stage.